Today we will be finding probability of compound events. Okay, before we work on compound events, I want to do a quick review of simple probability. Okay, and simple probability is like the probability of flipping heads when you flip a coin. Okay, heads occurs on one side of a coin, so it can happen one time out of two possible outcomes on that coin. There is heads and there is tails. Those are your two choices. Okay, so it's the number of what you're looking for, how many times the thing that you're looking for happens over the total possible outcomes. Okay, and that's going to give you your decimal as a percent. So 1 out of 2 is 0.5. So that would be a 50% chance of flipping a heads. Okay, which is why they use that for sports to start the game, who starts with the ball in football. Okay. Um, let's take a look here at some compound probability. The compound probability is looking at the probability of multiple things happening. Okay, so if you flip a coin and then roll a dice, or flip a coin twice, or you have pants and shirts, what's the total possible outcomes of wearing khakis and a white shirt kind of a thing, okay? Compound is when we've got those multiples, all right? So a new school uniform consists of khaki pants and blue jeans with a maroon, black, or white polo shirt. Using an organized list or table, what is the sample space of possible outcomes? That just means what is the total um, options. What are all the options? So you could have khaki with a maroon. You could have khaki with black. You could have khaki with white. Okay. Then you could have blue jeans, right? Blue jeans with maroon, blue jeans with black, and blue jeans with white. Okay. So that means these are your sample space. Okay. Number three is going to be very similar to that. You can list those all out. Or, sorry, number two. All right, number three has some of this listed, but then it wants us to construct a tree diagram. Okay, a tree diagram is if I have my 32 ounce, so it says Fancy Canteen makes custom water bottles with choices consisting of container size, color, and dispenser type shown in the table. Each canteen is a selection of the three different customizations. A customer randomly chooses a custom water bottle. Construct and use a tree diagram to determine the sample space, how many different options there are, and what the different options are and how many there are. Okay, so with the 32 ounce, we can get white, yellow, or blue. With my 32 ounce white, I can have a pop top or a twist top. With my 32 ounce yellow, I can have a pop top or a twist top. With my blue, I can have a pop top or a twist top. Okay, so I've got 6 total answer choices right there. Now with my 96 ounce, I can have white, yellow, or blue as well with pop top, twist top, pop top, twist top, pop top, and twist top. So I have 6 more possible choices. So that makes 12 total different types of canteens that we can make with that. All right, so these are my sample space as a tree diagram, and my number is 12, my total possible outcomes. Okay, you can try number 4 like that on your own there. Now, number 5 here, it says the spinner shown has 6 equal sized sections and is spun twice. What's the probability of spinning a sum of 6? Okay, well, if we list out all of our choices, we have 1, 2, 3, 4, 5, and 6. With my first roll, I can roll any of those. With my second roll, I can also roll a 1, 2, 3, 4, 5, or 6, right? Then with a 2, I can roll a 1, 2, 3, 4. Okay, so you'll see there are 6 options for each of these numbers, which means a total of 36 options. Okay, possible outcomes. All right, now it says what is the probability? A sum of 6. Well, the 1 and the 5 make a 6, so there's one here. The 2 and the 4 make a sum of 6, so there's one option here. 3 and 3 would make a 6. 4 and 2 would make a 6, and 5 and 1 would make a 6. 6 can't be rolled with anything to equal 6, so there are 5 total choices, okay? And then we can divide 5 divided by 36, and that gives us 0.138 or 13.9%. Sorry, 88. So 13.9% is the probability of that. Okay, now with this next one, it says a six-sided cube with the letters SOLVED is rolled twice. What is the probability of rolling two consonants? Okay, so you can list out these just like we did on the last one and use the tree diagram and sample space to help. Or we can look at, okay, out of these, I have 1, 2, 3, 4 out of 6 that are consonants, okay? So I have 4 out of 6 that are consonants. Then when I roll these again, I'm going to have another 4 out of 6 that are consonants, okay? Then I can just multiply my simple probabilities in order to equal my compound probability. 6 times 6 is 36, which is 36 possible outcomes, which we know is true because of this one we did above. And then 4 possible, and 4 would make 16. Okay, now let's go ahead and just check our work here. If I get an S first, there are 4 more, an S, an L, a V, and a D that would make this true. Okay, if I get an O, there is nothing that's going to make that true, so that would be 0 here. If I get an L, there are 4 more. Okay, so that makes 4 more. If I get a V, there are 4 more. If I get an E, there are none. And if I get a D, there are 4 more that will make two consonants possible. 4 plus 4 plus 4 plus 4 is also 16. So you can see that either way that you do that, you're going to get that same solution there. Okay. And then if we simplify this simplifies to 4/9. Okay. And 4 divided by 9 is 0.4 repeating. Okay. Or 44.4%. Okay, so 44.4%. All right, so you can try that on number 7 and 8. And then let's take a look at number 9. And we're going to look at number 9 similarly to how we just did that last one. A coin is tossed 3 times. What is the probability of getting at least 2 heads? Okay, on the first roll, it doesn't matter what I get. So 2 out of 2 doesn't matter. Okay, on the second roll even, it does not matter what I get, heads or tails, right? Okay, but if on one of these first 2 I rolled a tails, I have to get a heads on that last roll. Okay, so 2 times 2 is 4, times 1 is 4. 2 times 2 is 4, times 2 is 8. So 4 out of 8 are at least heads. And now let's double check this. If I have heads and tails, I can have heads or tails, then heads or tails, then again, heads or tails. Okay, if I roll tails, tails, there's nothing here that will give me 2 heads, right? Here I have one possibility if I roll a tails first. Okay, on this one, I can get heads again, that would count, 1. I can get a tails, that would count, that's 2. If I get a heads on that third one, even though I rolled a tails, that's a third one, and then a tails. So that's 3 out of the 4 there. So total is 4 outcomes out of, again, 8. So you can see either way you do that, you're going to get that same answer. Okay, and you can try this on 10, 11, and 12 on your own.